Hey guys, so today we're going to deal with equations with fractions or involving fractions as part of equations and formula. Let's start. So as you know from previous or as basic knowledge, we have inverse operations, which are the opposites that we use in order to get the pronumeral by itself. As I always like to say, I like to think of it as a game where x or y or whatever pronumeral you're using needs to be by itself on either the left-hand side or the right-hand side of the equals, and we slowly get rid of everything else that's with it. There are a few rules that we need to know in order to do equations, so let's quickly go through them once more. Rule number one, whatever you do on one side, you must do on the other side to balance the equation. So whatever inverse operation you do on one side, you have to do it on the other side to balance it out. Rule number two, always leave your answer in an exact form. If the answer is always an integer or a terminating decimal, then that's fine. But if it's not, then you need to leave it in a fraction or a surd. Rule number three, when you have more than one thing with the pronumeral on that side of the equation, then you always leave whatever is directly with the pronumeral to last, and you get rid of everything else first. Rule number four, if there are grouping symbols or brackets, then expand those brackets first before you decide to move forward. And rule number five, if there are pronumerals on both sides, like if there's x's on both sides of the equal, we move the smallest one across. If you have any issues with steps or rules, 1 to 5, please watch the other videos about equations that have been made before. Now let's jump into some examples. So let's look at example 1. With example 1, I have x divided by 4, or x over 4, plus 3 equals 9. So I have a fraction there. And the rule is, leave whatever's directly with the pronumeral to last. In this case, the divided by 4 is with the pronumeral. So I'm going to leave that to last, and I'm then going to get rid of the plus 3 first. The inverse, or opposite of plus 3, is minus 3. So I'm going to minus 3 on one side, and I'm going to do it on the other side. Because remember, whatever you do on one side, you have to do on the other side. So that eliminates that plus 3. Now I'm left with x over 4 equals 6. Now x over 4 as a fraction can also be read as x divided by 4. So the opposite of divided by 4 is times 4. And whatever I do on one side, I have to do on the other. So that cancels that 4 out there. And I'm left with x equals 24. Let's go on to the next example. Now the next example is a little bit different because you have 3x plus 2 all over 4. So now, directly with the pronumeral is the times 3. After the times 3, the next thing that's with the pronumeral is the plus 2. And then after the plus 2, the thing that's with the pronumeral is divided by 4. So the last thing that's there with the pronumeral is a divided by 4. So that's the first thing I get rid of. I can't touch the top of this fraction until I start getting rid of what's underneath as a denominator. The opposite of divided by 4 is times 4. So I do that on both sides. There is another method here you could use, which is cross multiplication, but we're not going to get into that now. So we multiply both sides by 4. So that 4 is eliminated. Now let's move on. So now we have left 3x plus 2 equals 4. Leave whatever's with the pronumeral to last. So I'm going to leave that 3x to last. And I'm going to get rid of the plus 2. The inverse of plus 2 is minus 2. And whatever I do on one side, I have to do on the other. So that gets rid of that 2. And now I'm left with 3x equals 4 minus 2, which is 2. And now I have divided by 3. Why? Because that's 3 times x. And the opposite of 3 times x is divided by 3. Whatever I do on one side, I have to do on the other. So now that 3 is eliminated, I have x equals 2 over 3. And I've left it as a fraction because it's not a terminating decimal or a whole number. Let's go on to example 3. Now with example 3, it's very similar to example 2. So same steps. Let's go through it. 4 minus y. Well, just to make life a little bit easier, I'm going to write 4 minus 1y, just so I know what's happening. So, directly with the pronumeral, I have minus 1 times y. After the minus 1, I have the 4, that's with the pronumeral. And lucky last, I have divided by 2. So that's the first one I'm going to get rid of, the last thing that's with the pronumeral. Remember, we can't touch the top until I get rid of the bottom. So, the opposite of divided by 2 is times 2. And whatever I do on one side, I have to do on the other. The issue here is, it's going to be everything on the other side times 2. Don't make any silly mistakes, it's every single thing on that side times 2. In example 2, there was only one thing there, so it didn't make a big difference. But in example 3, there's 2 things on the other side of the equal, so it's everything times 2. So now that that's eliminated, I'm left with 4 minus y equals 2 times y plus 2. So I need to expand these brackets. Remember, if there's brackets within an equation, it's so much easier to do the equation if you just expand those brackets to begin with. So once I expand the brackets, I get to that. Now I have pronumerals on both sides. And remember, the easiest thing is to take the smallest value across. Negative 1 is smaller than 2. So I'm going to take minus 1 times y across. Minus 1y, the opposite is plus 1y. So I do that on both sides. Now that eliminates this. So now I'm left with 4 equals 3y plus 4. So now I want to get y by itself here. There's 2 things with the y. Directly with the y is the 3 times y. And then after that, there's a plus 4. So we leave whatever is directly with the pronumeral to last. And I'm going to get rid of the plus 4 first. The opposite of plus 4, or inverse of plus 4, is minus 4. And remember, whatever I do on one side, I have to do on the other side. So I'm left with 0 on that side, because 4 minus 4 is 0, equals 3y. But y is still not by itself. We have 3 times y. So what's the opposite of 3 times y? Divided by 3 on both sides. So I'm going to divide both sides by 3. That cancels this out. And I'm left with y equals 0. Sometimes you can get the pronumeral equals 0. Let's move on to example 4. Now example 4 is a little bit trickier now. You have 2 fractions on this side, and you have a number or another elements on the other side. Before I can start working with the x's, I need to simplify these fractions. And in order to simplify these fractions, I need to add them. Now, as you know from addition of subtractions, in order to add fractions, the denominators have to be the same. If they're not the same, we use the butterfly method. Now, if you don't know what that is, please go back and watch adding and subtracting fractions. The butterfly method basically is you get this denominator, the first denominator, and you multiply top and bottom of the second fraction with it, and you get the first denominator and you multiply top and bottom of the other fraction with that, as you can see there in the green. So now we can do 3 times x, 3x, 2 times x, 2x, 2 times 3, 6. So now we've simplified that into one fraction. We simplified that fraction into 1 with the same denominator. We can further simplify the top now by collecting like terms. 3x plus 2x, which is 5x. But first, I got rid of the 6 here before I simplified the top. Doesn't matter which you do first, but I can't touch the top until I get rid of that divided by 6. The opposite of divided by 6 is times 6. Whatever I do on one side, I have to do on the other side, as you can see there. So that eliminates that. Now I'm left with 5x up the top equals 5 times 6. So don't skip steps. Always make sure you go through slowly until you get the hang of it. 5 times 6, which is 30. Now I have 5 times x. What's the opposite of 5 times x? Well, it's divided by 5 on both sides. So when I get rid of this, I have x equals 30 divided by 5, which is 6. Let's go on to the next example. The next example is a very common example when you have one fraction with an equals and another fraction on the other side. So that is, you have AB equals CD. That's the syntax we like to call it. When you have a fraction with an equals and another fraction, the easiest way to solve this is to cross multiply. What that means is that you multiply the x with 3 and you multiply the 4 with the top there. You can see that x. So when I multiply 3 with x, I get 3x. And then when I multiply 4 with everything on top, I get that. I have brackets now. So I need to expand the brackets to simplify. 4 times x is 4x. 4 times 1 is 4. And now I get to an equation where pronumerals are on both sides. Remember, when we have pronumerals on both sides, we move the smallest one across. So the smallest one here out of 3x and 4x is 3x. The opposite or inverse of 3x is minus 3x on both sides. So that cancels this out. Now the tricky thing here is there's nothing left on that side of the equals. So it's 0 left on that side. So now we have 0 equals x plus 4. Well, what's with the pronumeral here? There's a plus 4. Let's get rid of that plus 4. The opposite of plus 4 is minus 4. Whatever I do on one side, I have to do on the other. So now I have minus 4 equals x, and they're equal to each other. Therefore, x equals minus 4. Hopefully, you understood that. Let's move on to the last example. Now, the last example is a little bit trickier because we have a few things happening here. Although we do have an equals with one fraction on this side, there are two fractions on that side. Really, because a whole number is also a fraction. A whole number is always over 1. So, for example, in this case, 4 is the same as 4 over 1. If that was 126, that will be the same as 126 over 1. So now, I have two fractions on this side, and as we did in example 4, in order to add them, the denominators have to be the same. And they're not the same. So I'm going to use the butterfly method again. Once I use the butterfly method, I get to something like this. Now, just like we did in example 5, you have a fraction with equals and another fraction. So we can do the cross multiplication. X times 5 and 10 times all of that, x plus 20. Now, just like in example 5, we have to expand the brackets. Whenever you have equations with brackets or grouping symbols, remember the rule, expand the brackets. It makes your life so much easier. 10 times x, 10x, 10 times 20, 200. Now we get to an equation where pronumerals on both sides. Remember the rule? When there are pronumerals on both sides, we take that's right, smallest one across. So the smallest one out of 5x and 10x is 5x. So I'm going to minus 5x's on both sides. Whatever I do on one side, I have to do on the other. Well, that eliminates this. So now I have nothing left on that side, which means I write 0. 0 equals 5x plus 200. Now remember the next rule. Leave whatever is directly with the pronumeral to last. So we're going to leave the 5x to last. We're going to get rid of the plus 200 first. The opposite of plus 200 is minus 200 on both sides. That eliminates that. Now I'm left with minus 200 equals 5x. Now that's 5 times x, so we're going to divide both sides by 5, and I get 40 equals x. Because they're equaling each other, x equals 40. There's a lot happening there, and you may need to look at that again. So maybe rewind the video, watch it slowly, and write notes on each step. There's a lot of things happening there and a lot of tips and tricks. So maybe pause it and write all the steps down to make it easier for you to remember. Now here I have a few quick questions for you to try yourself. Remember, follow the steps that were given above and look at your notes on the topic as well. Pause the video, try these examples, and come back for the recommended answers. There's the recommended answers. Hopefully you got them all right. If not, go back and watch the video again. Till next time, take care guys.